In today's video, I would like to introduce you a very nice and interesting function. It's called the floor function. So here is the following statement. We have the floor of fifth root of x equals floor of square root of x. So I'm going to solve this equation for x. So as you know, x is a real number, but the floor of x is an integer. The integer could be positive, it could be negative, okay? So by the definition, the floor of x is an integer is less or equal to x. So here is the following inequality. X is between n to n plus number 1. X equals n, but not equals n plus number 1. So there is another extra information about this one. So if you calculate the difference x minus the floor of x equals something equals fraction, okay? Where is the fraction? X from this set, from 0 to 1, okay? Not include number 1. It can go all the way down to the 1, but it's not 1, okay? So for example, let's take the floor of 7.8 equals 7. X is representing 7.8, but the floor of x is 7. This difference, which is 0.8, is called fraction, okay? Is always in this set. So let's take the negative number, minus 3.2, okay? Is not minus 3, is minus 4. This is how it goes. Always ground the number down, okay? This is the definition of the floor. Now let's go through solution. So let's set floor of square root of x equals n as an integer, and the root fifth of x equals also n because we have equality, okay? So by the definition of the floor, I'm going to apply this formula, this inequality. So I have n is inferior or equal to x. X is strictly inferior than, square root of x is inferior to n plus number 1, strictly inferior than n plus number 1. For the second statement, we have fifth root of x is always between n and n plus number 1, not including n plus number 1. So I'm going to take this both inequalities. I'm going to square this one. I'm going to raise number 5 as a power for the second inequality. So we get the following inequalities. I get n squared is inferior to x is strictly inferior than n plus number 1 quantity square. For the second inequality, I get n to the fifth is inferior to x is strictly inferior than n plus number 1 to the fifth, like this, okay? Before I continue working on this one, I'm going back to check x is positive or negative. It's impossible to be negative because we have the square root of x, which means this side of the equation is positive, which means the other side of this equation must be positive as well, which means x is always positive. Since x is positive, I'm going to deal only with positive numbers. I'm going to create a lone inequality by combining these two inequalities. So we know n squared is inferior to n to fifth because we have n is include 0 too, okay? So n is a non-negative integer, okay? So it's strictly inferior by the definition is inferior to x as we have here. In the same time, x is strictly inferior than this one, n plus number 1 quantity square, based on the first inequality. And also n plus number 1 square is strictly inferior than n plus 1 to the fifth. What I'm going to focus on, I'm going to focus on this central inequality, these terms, okay? I'm going to work on this portion. I get n to fifth is strictly inferior than n plus number 1 square, okay? This one is verifying this inequality, but which point is verifying this one, okay? We are going to determine where we have restriction point, where we have this inequality hold, where we have not hold. Okay, so I'm going to check the sign of this one by calculating the difference of this one, which is n to the fifth minus n plus number 1 quaternary square is strictly inferior than 0. Okay, let's define a new function. Let's call it f of z equals z to the fifth minus z plus number 1 square. Okay, in order to make the comparison between this term and this term, by plugging n equals 2 here, I get here 2 to the fifth, which is 32. I get here 2 plus 1, which is 3 square, which is 9. It's impossible to, at this point, we should work out to see what's going on after this point. I'm going to calculate f of 2. F of 2 is given as I said, 2 to the fifth minus 3 square, which is 23, which is positive. Okay, I'm going to check this function is increasing or decreasing, and by calculating the first derivative function for this one, equals 5 is multiplied by z to the fourth minus 2 times z plus number 1. By applying the derivative function rules, I get this one. If it's clearly this one is strictly superior than 0. Why that? Let's take this term to the right to see what's given us. 5 z to the fourth is strictly superior than 2 is multiplied by z plus number 1. For all z is superior to 2. Plug in any number after 2, including number 2, you get this term is positive, bigger than this term. Because here is positive term here, because we have the fourth power. This one is always greater than this one, because due to the quadratic binomial is going quickly than the linear form, which means this one is always bigger than this one, which means this function is increasing due to this sign, which is positive. Okay, since this function is increasing function over z superior to 2, especially I'm going to calculate f of prime of 2 is given as always 5 2 to the fourth minus 2 plus 1, which is 3. Without doing the calculation, it's obviously is strictly superior than 0. Okay, by the way, in order to determine the critical point of this one, we need to calculate a second derivative function for this one, which means you get here 4 is multiplied by 5, which is 20 z to the 3 minus 2. To determine the critical point of this one, we get very small roots here, very small roots, which means we are far away from number 2. So we are in the safe spot, which means we'll have no critical points above this point 2. Okay, so which means we don't have to worry about the sign of this function to make us a problem. So we know this function, derivative function of this one is superior, is strictly superior than 0, which means this function is increasing above this integral. In addition, we know this function is positive because we have calculated f of 2 is given as a positive number, and which means it's going to contradict our assumption here, because we're supposed to have this one is strictly inferior than 0, but we found f of z superior to 0 above this point, which means we have no solutions for this inequality above this point, including number 2, which means n, it can be 0, it can be 1. Okay, so the only option for n. So now we are going to check these 2 points where we have solution. If n equals 0, by plugging this one into first this inequality where we have focus on this one, so 0 is inferior to x, x is strictly inferior than 0 plus number 1, which is 1. Here is the first solution. For the second solution, when we have n equals 1, I get here also 1 is inferior to x, x is strictly inferior than 1 plus 1, which is 2, 2 squared, which is 4. Okay, this is the only solutions that I found. So I have ended with this video. If you have any question or just put it in the comment section below. Don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.